So, hello. My name is Arnau Prat. I'm from Barcelona, from UPC, from DAMA UPC, Data Management Group, as well as the Smart City Technologies. And I'm also the Social Network Benchmark Task Force leader. And before starting with all the presentations about the user experiences with SMB, I will briefly introduce the benchmark. And a good way to introduce the benchmark is to go to the website and to see how a benchmark developer or benchmark implementer will proceed. So this is the LDBC Benchmark Council website. So if you go to the developer section, actually to the social network benchmark section, you will find this page where you find the different repositories where you can find the specification, the first case, then the data generator for generated the data of the driver of the benchmark, and the LDBC execution driver. So if we go to where the specification documents are uploaded, here we find the different versions of the different versions of the specification. Now I will open the latest one, which is 0.2, which was released just one or 2 days ago. And this is the document. The LDBC, as Peter said before, the LDBC Social Network Benchmark. It's a comprehensive benchmark that tries to model different use cases of database or graph database technologies. In this case, currently in the public draft, only the interactive workload is specified, but we plan in the following weeks to also add the BI intelligence, the business intelligence workload. Basically, the LDBC Social Network Benchmark is built on top of a social network. We synthetically generate a social network because we think that a social network is a very representative use case of graph application that allows us to implement different types of workloads, from the interactive one, which is composed by more simple queries that should be able to be answered interactively. Then we have the BI intelligence workload, which is expected to propose or to define more complex business intelligence queries. And finally, we expect to also define the graph analytics workload for more graph analytics like queries. So I will show you now an example of one of the queries of the interactive workload. If we go to page 76, we will here we have an example of the first query of LDBC interactive workload. We see the first thing we see is that the query is specified using natural language, English. So we have worked a lot to remove any ambiguities that could arise in this specification. We have received a lot of feedback from people. I would like to especially thank Tomer for being so persistent on on correctly defining the query. So thank you. Also, I would like to ask you, for those who would like to implement the benchmark, please implement it and send feedback. Do not hesitate to contact us, because we really appreciate this feedback. So in this case, this query, which is the first one, is called friends with a certain name. These queries, although they are designed or they follow a choke point-based design, they are also taken from real use cases. So these are queries that you will typically find, or you would like to execute on a real social network. So, for instance, in this case, we have given a start person, find up to 20 persons with a given first name that the start person is connected to, excluding that person, by at most 3 steps via nodes relationship. Then return the persons, including the summaries of the person's workplaces and places of study, summaries of the ascending by their distance from the start person, for persons with the same distance sort ascending by their last name, and for persons with the same last name ascending by their identifier. It's important here to have a total sorting or a deterministic total sorting ordering in order to avoid, when we validate the queries, to avoid mismatches in the results. Once we have in the description, we have the different parameters, input parameters of the query with their type, which are specified as well in the specification, and then we have all the results for each of the results the query returns, all the entries this result must contain. So we have this for all the queries, for the 14 queries. Also, we have now also the specification for the update queries, which was not available in previous versions. So this is one of the new additions of the new version of the specification. And in the appendix, you can find reference implementations for the different systems. In this case, we have Virtuoso with SparkQL, Virtuoso with SQL, also Sparksy with his API, and Neo with Cypher and API. So in case you want to implement the benchmark using these systems, here you will find the query implementations. So I think we can now move to the series of presentations about the experiences of the different vendors with the benchmark. Start for Alex.